Okay, guys, we are getting close to the end of this problem. In numbers 4 and 5, they want us to actually graph the solutions to your inequality. So we need to actually take a look at our inequality first, which was up here. So I'm going to write that down as 9n plus 5b has to be greater than 100. So there's our inequality. And if you'll notice, they put necklaces, which I was calling n, they put that on the x-axis. So instead of 9n, I'm just going to go ahead and write it as 9x. And then they're putting bracelets, which is b, on the y-axis. So we're going to call that 5y, greater than 100. So in order to actually graph our inequality, we need to draw that line first. And this is not in y equals mx plus b. So if you'll remember all the way up from the very first problem, 22.1, to make a quick sketch of this graph, we want to just look at our two important points, our intercepts. So we've got x over here, which is necklaces, and that's at $9 a necklace. We've got Y, which are bracelets, and that's at $5. So let's assume, just pick our two intercepts. Let's assume we don't sell any of our necklaces. That means I have $100 that I want to make, and I got to make that out of bracelets. So 100 divided by 5 is going to give me 20. So there are my intercepts. My 2 points. So 0, x is 0, y is 20, all the way up here. And let's flip-flop. Let's say I don't sell any of my bracelets. That means I need to make $100 out of necklaces. I don't like how that's thicker. All right, let's do that. So I got to make $100 out of necklaces. So we're going to do 100 divided by 9, and that's not going to go in evenly. 100 divided by 10 is 10. So 100 divided by 9, it's just a little bit more than 10. So just to double check, it's going to, nope, I want my calculator. 100 divided by 9 is going to give me 11.1. So we'll just go ahead and call that 11. So that's my other intercept, 11 comma 0. So 8, 9, counting by tens, so 11, so right around there. And we're going to go ahead and draw a line through it. Remember, this is probably the quickest way to graph a line and put it through these 2 points. Now this is a strict inequality, so I'm not going to make a solid line. I'm going to go ahead and make it dashed because I want to make more than 100. I don't want to make exactly 100. So I'm going to go ahead and see if I can dash along there. There you go. Perfect. Now the question is, am I going to shade, because with inequalities you have to shade a region. So should I shade the region over here in region number 1, or should I shade region number 2? So if you'll remember from the beginning of this problem, I want more than $100. And one of those combinations that we came up with that gave us more than $100 was 20 bracelets and 10 necklaces. So 20 bracelets, bracelets is actually the Y, so 20 bracelets and 10 necklaces. So let's go ahead and plot that point 10 comma 20. So here's 10, up here is 20. This was a point. So that means that all of the points above this line are going to be solutions to my situation. So everybody in region 1 above that line, and I'm going to get right over there, is going to give me a profit greater than $100. So number 5 is asking, is 3 comma 18.6 a solution to my inequality? Explain your reasoning. Well, let's go ahead and figure out where that point lies. 3 comma 18.6 is definitely Here's 18, 18.6 in my shaded region. So we're going to go ahead and say, yes, this point lies in my shaded region. So it's a solution. And you're more than welcome to double check it with some math by doing, multiplying the 3 by $9 and then multiplying the 18.6 by 5, and you're probably going to find out that it's going to give you more than 100. However, you might be thinking what I'm thinking, which is 18.6 represents the number of bracelets. And no one's going to go in there and buy zero point 0.6 of a bracelet. So I'd like to point out that yes, this may be a solution to the inequality, but it's not a realistic solution to my situation. I know it's been a while since we talked about it, but I would go ahead and say that it may be a solution to my inequality, but I would not find this in the domain or the range of my inequality because it's not realistic.